Hey everyone! Welcome back to the Programming Professor's channel, where we unpack the secrets to writing readable, maintainable code. Today, we're diving into function design, creating clean and maintainable code, drawing insights from Robert C. Martin's Clean Code, specifically Chapter 3 on functions. I've distilled these concepts into a slide deck we'll explore together, packed with tips to make your functions shine. Clean functions aren't just fluff. They're the backbone of readable, debuggable, and scalable software. So, grab your coding fuel, and let's level up your function game with some Uncle Bob wisdom. Function design, creating clean and maintainable code. Based on Functions from Clean Code by Robert C. Martin. Here's the game plan for today's video, straight from our outline slide. We'll kick off with a look at the historical context of functions, how we got here from the wild days of early programming. Then we'll make the case for small functions, showing why less is more. Next, we'll focus on keeping functions sharp with the single responsibility principle and consistent abstraction. Naming for clarity comes up after that, because a good name is worth its weight in gold. We'll tackle managing arguments and side effects, followed by error handling and code reuse strategies like dry. Finally, we'll wrap up with the process and principles for crafting clean functions. It's a tight roadmap, so let's dive into the story of clean code. Functions have come a long way, and this slide takes us through that evolution. Back in the early programming era, we had routines and subroutines, basic blocks with limited abstraction, all about controlling procedural flow. Then came the middle period with Fortran and PL1, introducing programs, subprograms, and the first taste of functions as we know them. Fast forward to the modern era, and functions are the backbone of our code, especially with object-oriented design pushing for clean, maintainable systems. It's a journey from chaos to clarity, and understanding this sets the stage for why function design matters today. Big functions can be a nightmare, and this slide shows us why with a messy example from a testing tool. The code's a beast. It's got a wiki page, a string buffer, nested conditionals, and cryptic setup logic all jammed together. It's hard to follow, tough to debug, and screams, "Refactor me." This is the kind of function that makes you question your life choices as a developer. It's doing too much, and we're about to see how to fix it. Now check out this glow-up. We've refactored that monster into something clean and clear. The new function has a descriptive name, render page with setups and teardowns, that tells you exactly what it does. It checks if it's a test page, then hands off complex setup and teardown logic to helper functions, keeping everything at one level of abstraction. The flow's obvious: setup, content, teardown, done. It's like turning a rambling novel into a crisp short story, way easier to read and maintain. Small functions are where it's at, and this slide lays out the best practices. Historically, a function fit on one screen, about 24 lines, but today we aim for 20 or less, sometimes even 2 or 3 lines. Why? They're easier to understand, test, maintain, and reuse. Plus, they document themselves better. The catch is it takes planning, solid naming, and a coherent structure to pull off. Think of it as writing haikus instead of epic poems, short, sweet, and powerful. The single responsibility principle, or SRP, is our next stop. It's simple: a function should do one thing, do it well, and do it only. How do you spot one thing? Look for statements all at the same abstraction level, where you can't extract more without just parroting the code, and it describes a single operation. It's about focus, keeping your functions laser-sharp and free of clutter. Here's SRP in action with some examples. The good version is a tidy function that saves a user by validating, formatting, and writing to a database. 3 steps, one clear job. The bad version. It's a mess, validating emails and passwords, formatting names, updating databases, sending emails, and tracking stats. It's like a function trying to be the whole app. SRP keeps things tight and purposeful. Consistency is king, and this slide shows why functions need one level of abstraction. The messy example mixes high-level logging with mid-level validation and low-level database calls. It makes your brain do gymnastics to follow it. The refactored version lifts everything to the same level: validate, save, notify. It's smoother, cleaner, and doesn't make you squint to figure out what's what. Ever read code that feels like a story? That's the step-down rule. Code should flow top-down, with high-level functions calling into detailed ones, like chapters leading to paragraphs. It's all about readability and maintainability, making sure someone or future you can skim it and get the plot without a headache. Switch statements are tricky, and this slide calls them out. They inherently do multiple things. One case for commissioned pay, another for hourly, another for salaried. It's a bloated function begging for trouble. The fix: polymorphism. Let each employee type handle its own pay calculation. It's cleaner, more extensible, and keeps the function focused. Names matter, and this slide nails it. Good names like insert customer, is valid account, and find customer by ID tell you exactly what's happening with consistent verbs and clear purpose. Compare that to process, check, and get data: vague, lazy, and useless. A solid name is like a book title. It hooks you and sets the scene. Arguments can make or break a function, and here's the rundown. 0 arguments nuladic is the dream. 1 monadic is solid. 2 dyadic needs caution. 3 triadic is a red flag. And more than 3. Time to rethink. Avoid output and flag arguments, such as booleans, as they can muddy the waters. Keep it simple and clear. This slide illustrates why too many arguments are problematic. Imagine a function designed to create a circle with parameters for x, y, radius, border, color, and filled status. 6 arguments in total, leading to potential chaos. Instead, bundle related parameters into an object, like a circle class with a point and radius. Fewer arguments lead to less confusion, akin to trimming a rambling sentence into a concise phrase. Side effects can be sneaky, and this slide exposes them. The poor example checks a password, but surreptitiously initializes a session. Quite the surprise. This misleads anyone reading the function's name. The solution is to split the responsibilities. One function checks the password, while another handles the session. No hidden twists, just straightforward honesty in your code's narrative. Command query separation is a valuable principle. Functions should either perform an action, like saving a record, or answer a question, such as determining existence, but not both. It's about intent. Commands change things, queries report things. The benefits include clearer code, easier testing, and better separation of concerns, keeping your code's storyline cohesive. Next up is error handling, and this slide offers valuable insights. Abandon error codes in favor of exceptions. They're cleaner and prevent cluttering your flow with nested if-else statements. The example showcases a file deletion function with a try block calling a helper and catching errors separately. It's like keeping the drama off the main stage, tidy and professional. Dry is all about efficiency. The poor example repeats a greeting message for both email and SMS. Double the work and double the trouble if changes are needed. The solution extracts the message into a create message function. Less code, fewer bugs, and easier updates. It's akin to cutting redundant scenes from a script. Structured programming maintains discipline. Single entry and single exit points mean no abrupt returns mid-function. and deep nesting should be avoided as it creates a maze. The poor example has multiple return statements. The refactored version consolidates them into one clear check. It's about keeping the narrative straightforward, not a choose-your-own adventure. Writing clean functions is a process, and this slide outlines it. Begin with working code. Don't worry about size initially, just make it functional. Add tests to solidify it, covering edge cases. Refactor by extracting methods, renaming, eliminating duplication, and simplifying. Then, review with peers for fine-tuning. It's like drafting a novel. Start rough, refine, and polish. Here's a roundup of best practices. Keep functions small, with one responsibility and consistent abstraction. Organize using descriptive names and command query separation. Handle errors with exceptions, keeping them separate. Test thoroughly and maintain coverage through refactoring. This is the recipe for code that excels. In conclusion, functions are the building blocks of your code. Craft them cleanly, and your software remains maintainable. Adhere to principles like SRP, command query separation, and dry. Start simple, refactor frequently, test rigorously, and review consistently. This is the path to code you'll be proud of. Thanks for watching. Let me know in the comments if there are other topics you would like me to talk about. If you enjoyed this video, please like, share, and subscribe for more content on software engineering and technology. See you next time.